Naming ions. So cations are the ones that are positive. And whenever you're naming their ion, it's very simple. You name the name of the metal, because cations are metal. Name the name of the metal and put the word ion after it. So for K+, we know it's an ion because it has a positive sign. It has a charge. So for a cation, you would name it with the name of the metal and the word ion. So we have the name of the element and the word ion. So when you see the word ion after an element name, you know it's a cation. Oppositely, for an anion, which is a negative ion, remember An ion, a negative ion, they're written with the name of the element, but the suffix now is "ide." So chlorine normally is chlorine, now it is chloride. So you change the suffix to "ide." We don't use the word ion. We don't say chloride ion. That's redundant. Changing it to "ide" means it's an ion. Okay? So when you put "ide" at the end, then you know it's an anion. So if we look at the examples, O2 minus. Well, oxygen is a nonmetal. It also has a negative charge, so we know that this is going to be an anion. So to name it, we have ox, but instead of oxygen, oxide. Okay. And if you start thinking about chemicals you've heard all your life, carbon monoxide, oxide, right? That's where that "ide" comes from. Okay. Mg plus 2 has a positive charge on it, which means it is a cation. It's also a metal, which means it is a cation. So we'll put magnesium ion. Now number 2 wants you to write the electron dot for each of the following. Some of them are elements, some of them are ions. So for the first one, a carbon ion, well, carbon can have a plus or a minus charge, so to figure out which one it is acting out right now, if it's acting like a cation or an anion, is based off how it's named. Carbon ion comes from cation, so that means we're talking about carbon with a 4 plus charge. Carbon normally has 4 dots around it, but if it's 4 positive, that means it's lost 4 electrons. You don't put any dots around it. It doesn't have any valence electrons on that outer shell. And then if I look for one that ends in "ide," like fluoride, but ends in "ide," I know it's an anion. So it would be F, and if I look at my periodic table, the charge is going to be F minus. Okay, if it's a minus, then it has more electrons than it does protons. So now I have F, and it normally has 7 dots, but if it went and gained 1, now it should have 8. 1, 2, 3, 4, 5, 6, 7, 8. If I was to show the electron configuration for each one, A through D are regular atoms, which we've done. For an ion, now we need to look at what happened to those electrons. So sodium ion, it ends in ion, it's a cation. Okay, for sodium, we have 1 S2, 2 S2, 2 P6, and then we normally have 3 S1. However, a sodium ion is Na positive. If I'm positive, that means I've lost an electron, right? I have more positives than I do negatives. If I've lost an electron, then the one that I would normally put as 3s1, the outermost electron, is now gone. Okay? If I had been talking about magnesium, the magnesium ion would be 3s2. It would have lost both of the electrons from 3s, and so now it would just still end at 2p6. So you need to keep that in mind when we're talking about the electron configurations with ions. you need to look at they lost electrons or they gained electrons. And you need to add that into their electron configuration. Add or subtract electrons from the electron configuration. Now, because our electron configurations change when they're an ion, we end up with what's called isoelectronic configurations. We already know that elements with similar electronic configurations tend to have similar chemical and physical properties, right? We know that if they have the same number of valence electrons, they're very similar. They're in the same family. It is possible, in fact common, for elemental ions to have not only similar but exactly the same electron configurations as other elements or ions. When two elements, and this is where our notes are, when two elements and or ions have the same electronic configurations, it is said that they are isoelectronic. Iso meaning same. If you think to geometry, there's a name of a shape that has two sides that are the same. What is that called? Isosceles, ISO. That ISO prefix means same. Isotopes, same element, different number of neutrons. So isoelectronic, they have the same electron configuration. When two chemical species are isoelectronic, they again tend to have similar chemical properties. So when they are isoelectronic, they have similar chemical properties. So for example, the lithium ion, since it is a cation, and helium both have an electron configuration of 1s2. Beryllium and helium both have 1s2, which also means lithium, beryllium, and helium are all isoelectronic. They all have the same electron configuration. F- and neon, fluoride and a neon atom, both have this electron configuration because fluorine gained one to have 2p6. Okay, there's plenty of examples here to look through. And you can have several different elements, all have several different elements with ions, all having the same isoelectronic configuration, which means that they have the same properties there. So if you look at this first example, we have fluoride. Fluoride, it's an anion, so we do F, look for its charge on our periodic table, F-. Number of protons comes from my atomic number, 9. Number of electrons, well, if I have 9 protons and my charge is -1, I must have gained an electron, which would be at 10. So I gained 1. Say how many they gained or lost. And it's isoelectronic with which noble gas? Well, when it gained an electron, it has the electron configuration of 1s2, 2s2, 2p6, which is the exact same as neon. Remember how I said that all the elements want to be like a noble gas, and when they become an ion, they have the exact same reactivity as a noble gas? It's because they have the exact same electron configuration as a noble gas.